Ever wondered how we're pushing the boundaries of space technology? From inflatable heat shields to next-gen rocket engines, the innovations are mind-blowing. NASA's low Earth orbit flight test of an inflatable decelerator and SpaceX's Raptor 3 engine are redefining what's possible in space exploration. But how exactly are they doing it? Stick around, because we're diving deep into these game-changing technologies and how they're setting the stage for the future of space travel. NASA's LOFTID, short for Low Earth Orbit Flight Test of an inflatable decelerator with a unique 6-meter or about 20-foot diameter inflatable heat shield, made history as the first of its kind to take on orbital re-entry. It's also the largest blunt-body atmospheric entry ever attempted. For decades, space agencies have been relying on rigid aeroshells to get people and cargo back from space. You know, the tried-and-true method with parachutes and retro-propulsion. But here's the catch. These aeroshells are limited by the size of the launch vehicle fairings, meaning they usually max out at about 4 to 5 meters. That's about 13 to 16 feet. That works for small payloads, but if you're dreaming of bringing back something bigger, you're going to need something bigger, a much bigger solution. That's where LOFTID comes in, breaking the mold and expanding the possibilities. This inflatable heat shield offers a much larger surface area during re-entry. More surface area means more drag, which means your spacecraft slows down more effectively. This is especially handy when you're trying to land safely on a planet with a thin atmosphere, like Mars, for example. Think of it like trying to stop a speeding car with a giant parachute versus a handkerchief. The bigger the parachute, the smoother the landing. Joe Del Corso, the mind behind the LOFTID at NASA's Langley Research Center, put it this way: we're looking at going from 1.5 metric tons, that's like a well-instrumented golf cart, to 20 to 40 metric tons. In other words, LOFTID could turn space delivery from tiny package to full-on space cargo status. With a larger deployable heat shield, spacecraft can carry bigger, heavier payloads. Think scientific instruments or even human support systems for planetary landings. LOFTID's creation didn't happen overnight. It's the result of 2 decades of research and development on hypersonic inflatable aerodynamic decelerator, or CHIAD technology, at NASA's Langley Research Center. Unlike traditional aeroshells that are constrained by the size of the launch vehicle, HIAD aeroshells can be packed down small for launch and then inflated before atmospheric entry. Once inflated, they create more drag and start the deceleration process higher in the atmosphere, which leads to greater efficiency and stability during re-entry. Okay, hold up. We've got a bird here absolutely crushing the dance floor. Look at those moves. Now that we've seen the real dance master, let's slide back into some space tech. On November 10th, 2022, LOFTID took the plunge. Literally. The aeroshell endured the fiery re-entry into Earth's atmosphere, showing off its stable aerodynamics across hypersonic, supersonic, transonic, and subsonic speeds. This wasn't just a smooth ride, though. We're talking about protecting a 1,100 kilograms or 2,425 pounds re-entry vehicle hitting the atmosphere at 8 kilometers per second or 5 miles per second, reaching Mach 30 and experiencing 9.5 Gs of deceleration. After all that, it gently splashed down in the Pacific Ocean, where it was recovered in near-perfect condition. Not too shabby for an inflatable, right? Since LOFTID's splashdown, NASA's been flooded with interest from companies and agencies eager to get their hands on HIAD technology. It's not hard to see why. This inflatable tech could be the future of re-entry, especially for Mars missions and other space adventures. Not to be outdone, Europe is getting in on the inflatable heat shield action too. In June, they kicked off the ICAR-US project, aiming to develop their own inflatable heat shield. The project is backed by some big names, including Germany's Atmos and the German Aerospace Center, or DLR, along with official space research centers from Italy and France. With 10 million euros in funding from the European Commission, the Icarus team is hard at work on a system that could protect precious cargo during re-entry and eventually be used for Mars missions. During the first phase, they'll be completing the mission and system design, while also working on ground-based tests of key technologies. In the second phase, they'll take it to the skies with a flight test on a sounding rocket, using a scaled-down demonstrator of their inflatable heat shield, in short, IHS. When packed inside the rocket, the IHS will have a diameter of about 50 centimeters, 20 inches. But once inflated, it'll expand to a full 3 meters or about 10 feet. And if all goes well, a full-scale version could reach a whopping 10 meters that's 33 feet in diameter. Now, here's a cute, thirsty hedgehog, because, let's be honest, you're not protected from this level of cuteness. I mean, look at those little spikes. Okay, let's get back to heat shields. Both LOFTID and IHS are proving that sometimes going big means going inflatable. Whether it's bringing back a space mansion or safely landing on Mars, inflatable heat shields are the future, and that future is looking pretty awesome. We've got more space tech coming your way, so don't forget to hit that like button, smash that subscribe, and ring the bell to stay up to date on all the latest space tech and out-of-this-world discoveries. Now, say hello to the Raptor 3 engine, a beast that's making all its predecessors look like ancient relics. Let's talk numbers, because Raptor 3 is packing some serious digits. This bad boy boasts a thrust of 280 tons force, that's about 617,000 pounds of power for the Imperial folks. And the cherry on top? It's giving us all that power without wasting too much energy. SpaceX isn't just sitting back and saying, good enough. They're already eyeing over 300 tons of thrust for future versions. That's right, 300 tons. So, if you thought Raptor 3 was a big deal now, just wait until it gets better in the next round of upgrades. To hammer home how much this is, let's do some quick comparisons. Raptor 3 is 36% lighter than the original Raptor 1 and cranks out 51% more thrust at sea level. Compared to Raptor 2, it's 7% lighter and delivers 21% more oomph. Basically, it's the rocket engine equivalent of your favorite superhero getting a major tech upgrade. In metric, Raptor 3 pumps out 2.75 million newtons of thrust, which is roughly equivalent to the weight of a 5-story building. For context, a typical 5-story building might weigh around 600,000 to 700,000 pounds. So, when the Raptor 3 fires up, it's like lifting an entire building off the ground, versus the Raptor 2's 2.26 million newtons. For those who love their Imperial units, that's about 618,000 pounds of thrust compared to 508,000 pounds. Let me tell you that 100,000 pound difference is a big deal. Now, strapping 33 of these monsters onto a super heavy booster, that's 90.75 million newtons, or 20.4 million pounds of raw power ready to launch. This is akin to the weight of over 127 average-sized homes, assuming that each home weighs around 160,000 pounds. Then you have a huge community being lifted. Now, if SpaceX pulls off that 300-ton thrust upgrade, each Raptor 3 engine would be pushing out 2.95 million newtons of thrust. Stack 35 of those on a super heavy booster, and you've got 103.25 million newtons, that's 23.2 million pounds of sheer force. To put it in perspective, the Burj Khalifa in Dubai, currently the world's tallest building at 828 meters, about 2,717 feet, weighs approximately 500,000 metric tons. With 103.25 million newtons of thrust, the super heavy booster could theoretically lift the Burj Khalifa off the ground and move it to a new location, as if it were a child's toy. Of course, this is a purely hypothetical comparison, as the Raptor engines are designed to propel rockets into space, not to lift buildings, but you get the idea. In a nutshell, SpaceX's Raptor 3 isn't just another rocket engine, it's a game changer, and possibly the coolest thing you'll hear about. So keep your eyes on the skies, because the next time you see a rocket launch, it just might be powered by this absolute unit of an engine. Space tech is evolving at light speed. With each upgrade and breakthrough, we're not just inching forward, we're leaping into a future full of bold, ambitious missions. The next few years are going to be wild. Now, if you thought LOFTID and Raptor 3 were game changers, wait till you hear about SpaceX's new spacesuit designed for the Polaris Dawn mission. This isn't just about looking cool in space, it's a game changer for private spaceflight, pushing the limits of what's possible. So, why not stick with the old suit? Well, because this new one is taking things to a whole new level, literally and figuratively. You won't want to miss it, so click on this next video and see what's coming next.